Greetings, sir. My name is Raphael, Lorenz, and Dimayuga, and I'm going to give a review of the Stirling engine-based combined heat and power technology. Yun po yung name ng research na gagamitin ko pang identify ng research gaps. So, the external combustion engine has historically played a vital role in the development of power generation and transportation. And despite its importance, it has gradually been replaced by internal combustion engines kasi maraming performance issues and shortcomings yung design niya. And marami pong akong nakitang research gaps before that, and I listed only 5. And yung objective ko po dito ay to identify the usual problems regarding the use of external combustion engine and to address the solutions for common ECE problems. So, the data gathered, makikita nyo po, ang thermal efficiency ng ECEs ay mas maliit compared sa internal combustion engine. And same as their power density. And makikita po natin sa findings na may 5 po akong pinoint: low thermal efficiency, bulky and heavy design, slow startup time, high water and fuel consumption on steam engines, maintenance and safety issues. Sa 5 pong yan, itatakal po natin mauuna ang low thermal efficiency. Despite their theoretical potential for high Carnot efficiency, the ECEs achieve only about 15 to 25% thermal efficiency due to major heat transfer losses. So, the slow thermal response and material constraints and indirect heating process further limit the performance under variable loads. And yung solution for that is to improve the low efficiency of external combustion engines. Advanced heat exchangers and better working fluids like supercritical carbon dioxide or nanofluids can be used to boost heat transfer and cut energy losses. And through computer simulations, and we need to design compact heat exchangers, and having heat storage materials can also help keep performance stability. And yung improvements po na yun can make ECEs more efficient, faster, and more competitive with modern style power systems. And the research methodology to be used is the study uses experiments and computer simulations and para ma-analyze using CFD to test different heat exchangers. Yung CFD pala is yun po yung nag-aalaw kung ma-analyze natin kung paano gumalaw ang heat and fluid sa loob ng system. And a small prototype will then be built to compare real results with simulations and confirm the efficiency of improvements. And yung social and technological entrepreneurship niya is advances in the heat exchanger design, high temperature materials, and working fluids are more efficient and suitable for clean startups. These innovations can be used for renewable power, waste heat recovery, and rural electrification, creating both business and social opportunities by providing affordable, sustainable energy, improved ECS supports for economic growth, job creation, and environmental protection. And yung next na research gap is bulky and heavy design. Kasi ang mga ECs often bulky and heavy because of their large boilers and heat exchangers, making them unsuitable for small or mobile uses. And this research is mostly focused on improving efficiency rather than reducing size and weight, leaving a gap in lightweight and compact ECE design. And the solution for this is to reduce the bulky and heavy design of the external combustion engine. We need to use lightweight materials like advanced alloys and carbon composites that can be used along with compact microchannel heat exchangers. And maganda yung modular design to make the engine easier to build and maintain, and to be used to adapt for different uses such as solar or waste heat recovery. And the research methodology to be used is the simulation and experiments to make an external combustion engine lighter without reducing the efficiency or strength. And yung results sa research methodology na to will compare weight and heat transfer and performance to standard ECs to create more compact and efficient engines. The social and technological entrepreneurship for this is using lightweight and compact designs. Entrepreneurs can develop smaller, more efficient external combustion engines for off-grid power, vehicles, and renewable systems. These innovations can lower costs, attract green investments, and create new business opportunities. Socially, portable ECS can bring clean, affordable energy to rural areas while supporting local jobs and sustainable development. Dito naman po sa slow startup time, they need heat for the working fluid and the components before producing power, unlike the internal combustion engine na kaya nilang mag-start instantly. So, ang solution para dun ay to reduce it. This study proposes using fast preheating systems, phase-changing materials, and smart controls. Electric or catalytic heaters and low-mass materials can quickly rise temperatures. And with sensor-based control managing heat flow, these methods can cut startup time by 60% and improve ECE performance in portable and hybrid system. The research methodology for this is using simulations and experiments para makita natin kung paano nga ba ma-address yung problem dito. Using CFD and thermal analysis to test different materials and heating methods. And the prototypes data will be analyzed, compared with simulations, and find the best setup for faster and more efficient EC's performance. Yung social and technological entrepreneurship dito, developing a fast start external combustion engine with smart controls, can create efficient and responsive power solutions for renewable, mobile, and backup energy uses. These innovations can attract green investments and support reliable energy access in remote or disaster hit areas. By making ECEs quicker and more practical, entrepreneurs can promote clean and affordable and community-centered energy systems. So, yung next dito ay high water and fuel consumption. ECEs, especially steam-based types, use large amounts of water and fuel because they need constant steam for generation and lose energy through exhaust and condensation. Research on water recycling and fuel optimization and heat recovery in small-scale ECEs is still limited. Developing closed-loop systems and alternative working fluids can greatly reduce use and make ECEs more efficient and sustainable. And yung solution dito ay using closed-loop systems, waste heat recovery, and alternative working fluids to reduce high water fuel use in external combustion engine. And these improvements could cut water use by up to 70%, fuel consumption by 2 to 30%, making ECEs more sustainable and practical. And the research methodology to be used is experimental and computational methods to design a closed-loop external combustion engine. And simulations and prototype testing will analyze performance, efficiency, and resource savings. And the goal is to develop an optimized ECE system that cuts water use by up to 70% and fuel consumption to 2 to 30%. And the social and technological entrepreneurship for this is the closed-loop ECE systems create opportunities for businesses and to design energy-efficient engines that recycle heat, water, lowering cost and emissions. These technologies can be used in industries or rural areas to provide sustainable, low-resource power. Overall, they promote clean energy, community empowerment, and support global sustainability goals. And lastly, we have the maintenance and safety issues. And the ECs face safety and maintenance issues due to high pressure and temperature, which can cause corrosions, leaks, or explosions. There is a research gap in developing smart monitoring and predictive safety systems that detect those problems early. So the solution is proposing a smart monitoring and automated safety systems with sensors and predictive algorithms to improve the safety and reliability of the ECEs. These systems can detect early signs of failure, automatically shut down during danger, and use durable materials to reduce maintenance. This approach makes ECEs safer, more efficient, and suitable for long-term energy use. And the research methodology for this is uses a quantitative, experimental, and computational approach to develop a smart monitoring system and safety system for the ECE by combining sensors, predictive algorithms, and simulations para maiwasan ang unsafe conditions para rin ma-extend ang lifespan ng engine. So the social and technological entrepreneurship for this is improving safety and reliability, benefits the communities by reducing accidents and making energy systems safer and easier to operate. Affordable smart safety systems can help local operators manage ECEs efficiently while creating jobs in maintenance and technical support. This innovation promotes sustainable technology and social development. And this ends my presentation, and thank you for this opportunity to talk about ECE. Thank you, sir.